Welcome to another video. In this video, I want to solve a question on chemical formula. The question goes thus. A hydride of carbon has a vapor density of 15 and contains 20% by mass of hydrogen. Calculate the formula of the hydrocarbon and write an equation to represent its complete combustion in oxygen. So if I'm to write the formula of this hydrocarbon, all I needed is to find the empirical formula, the molecular formula, and the structural formula. So when they said I should find the formula, so the formula is not restricted to empirical formula alone. So I'm going to find the empirical, the molecular, and the structural. Then the second part says that I should write the equation to represent its complete combustion. Now let's profile a solution to this. Now, a hydride of carbon, whenever they say a hydride of carbon means hydrogen and carbon alone. So that is hydrocarbon. Another name for hydride of carbon is hydrocarbon. So we have the carbon, we have the hydrogen. So percentage by mass on this column. Then the percentage by mass contains 20% by mass of hydrogen. That means hydrogen is 20% by mass. Now if hydrogen is 20 and we are having 100 as a whole, if we subtract 20 from 100, that means the remaining 80 is governed by the carbon. So the next line of action is to find the mole. So mole is equal to the reacting mass all over molar mass. The reacting mass of carbon is 12. So I'm going to divide 80 by 12. The reacting mass of hydrogen is 1. I'm going to divide it by 1. So the atomic mass. So this divided by this is 6.7. So reacting mass over molar mass, reacting mass over molar mass. So we give me the number of moles. So this divided by this is 6.7. This divided by this is 20.0. So the next line of action is to divide by the smallest mole ratio. So the smaller between the two is 6.7. I'm going to divide by 6.7 both sides. So at this juncture, 6.7 divided by 6.7. So my carbon, I'm having 3. Then in the hydrogen, I'm having 1. Then in the hydrogen part, 20 divided by 6.7, that is 3 points. That is approximately 3. Let's say 3.0. Just like that. Approximately 3. So the smallest whole number. So that means the empirical formula of the compound is, now carbon has 1 atom, the hydrogen has 3, that is CH3, just like that. So the empirical formula of that compound is CH3. That answers the empirical formula part. Because the question says find the formula of the compound. I'm going to find the empirical formula, the molecular formula, and the structural formula. And in the context, you were given the vapor density. And there is a relationship between vapor density and relative molecular mass. Twice vapor density is equal to RMN, relative molecular mass. That is the relationship between vapor density and relative molecular mass. And the vapor density is given to us as 15, so I can easily determine the relative molecular mass. So relative molecular mass is equal to 2 multiplied by, my vapor density is what? 15. 2 times 15 is what? 30. So having gotten the relative molecular mass, I can now use that to find the what? Molecular formula. How do I get the molecular formula? I will just say CH3 multiplied by an unknown expression N is equal to 30. Just like that. So I'm going to expand this using their atomic masses. So atomic mass of carbon is 12. Atomic mass of hydrogen is 1. 1 times 3, that is 3. Multiplied by N is equal to 30. 12 plus 3 is 15N is equal to 30. So if I make N the subject of the situation, I will divide both sides by 15. So n is equal to 2. So once my n is known as 2, I can easily determine my molecular formula. So if I plug in these 2 for n here, I will get my molecular formula. So CH3 multiplied by 2. 2 times C is C2. 2 times H3 is what? H6. So the molecular formula is C2H6. Now the next line of action is to determine the structural formula. So how do I determine the structural formula? This compound, the name of this compound is ethane, C2H6. That is ethane. So I'm going to draw the structure for ethane. I'm having how many carbon? I'm having 2 carbon atoms. So that is C, bonding to C. Then I will bond it with H. This will be bonded to another H. H, 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 H. It's complete. 1, 2, 3, 4, 5, 6. 6 hydrogen, 1, 2. So this is the structural formula of the compound. Then the B part. The B part goes thus. Write an equation to represent its complete combustion, the oxygen. Now, anytime we are talking about combustion of hydrocarbon, there is a way we write the general equation for the combustion of hydrocarbon. The general equation for the combustion of hydrocarbon is given to us as Cx Hy plus x plus y over 4 O2 move to xCO2 plus y over 2 H2O. So any chemistry student that can write this, it will be easier for him to balance the equation for combustion of hydrocarbon. Anything hydrocarbon, once this equation is used, we get it perfectly. So now the hydrocarbon in question is C2H6. As you know that combustion is the breaking down of compound in the presence of oxygen. So here, my x is equal to 2 and my y is equal to 6. So I'm going to plug in 2 for x, then 6 for y. So when I plug it in here, I will get the combustion. Now C2H6 plus 2 plus 6 over 4 O2 move to xCO2. My x is 2, CO2, then plus y over 2, 6 over 2, H2O. So I have C2H6 plus 6 divided by 4 is 3 over 2. That is 1.5. 1.5 plus 2, that is 3.5. That is 7 over 2. O2 moves to 2CO2 plus 6 divided by 3 H2O. So I can easily multiply 2 by 2 to remove this fraction. So I have 2C2H6 plus 7 over 2 multiplied by 2, that is 7O2, moves to 2 times this is what? 4CO2 plus 2 times this is 6H2O. So that is the end of the class. So this is the equation for the general combustion of ethane. So don't forget to like this video, don't forget to share, don't forget to subscribe at Hugo Calculus. Life is continuous, life is differentiable, life is integrable but not the best measurable. It is a diet.